When we start discussing the vastness of the universe, there are certain questions that inevitably come to mind. One of these questions is, are we simply too small, or is the universe just overwhelmingly enormous? Indeed, our universe is so incredibly vast that we needed to create special units of measurement just to describe the distances between celestial bodies. Hello, everyone. Even within our own solar system, reaching the nearest planet requires months or even years of travel, and even then, it is merely a single grain of sand in the vast cosmic desert. Welcome to our channel. Today, we will be discussing the immense scale of the universe. We'll talk about how much time it would take if you were to move to another planet, and whether it is even possible to travel beyond our solar system in reality. Sit back and relax, because this is going to be fascinating. Let's get started. How long would it take to travel to planets other than Earth? Every acquaintance you have, every person you love or hate, all beings born on this Earth start their journey of life on a small blue sphere floating in the dark ocean of space. Earth is the only place in the universe we can truly call home. However, no matter how much we love Earth, our curiosity and thirst for discovery and adventure push us to explore further. Humanity has only just timidly taken its first small steps into the exploration of nearby space. Our achievements so far include landing on the Moon and meticulously planning a trip to Mars. We deeply believe that one day such journeys will become commonplace. But in the distant future, will we ever be able to travel beyond the Milky Way galaxy? Unfortunately, the chances appear slim. This is due to the incredibly vast size of the universe. To understand the true scale of the universe, let's start with something smaller, our solar system. The Moon, which is the closest celestial body to Earth, is about 385,000 kilometers away. If you were to drive a car at a constant speed of 100 kilometers per hour without stopping, it would take you approximately 160 days to reach the Moon. You might wonder, what was the point of inventing spacecraft? Wasn't it so that we could travel through space in these vehicles? Indeed, you are absolutely correct. The first human flight to the Moon, which took place in 1969, took over 3 days. Even with modern rockets, it still takes about the same amount of time to cover that distance. You might think, a 3-day flight doesn't sound too long, does it? But keep in mind, on a cosmic scale, the Moon is just a stone's throw away. Now, let's imagine Elon Musk finally builds a cutting-edge spaceship and sets off for Mars. Since Mars's orbit around the Sun is elliptical, the distance between Earth and Mars is always changing. When Earth and Mars are at their closest, they are about 55 million kilometers apart. Suppose you were on a state-of-the-art airplane and the pilot decided to head for Mars. That journey would take 7 years. Of course, switching to a modern spacecraft and plotting the most efficient course would still take time. Even then, it would take 6 to 9 months to land on our closest neighboring planet and take a walk. Now, what if you wanted to get an up-close view of the Sun by flying a rocket to the center of our solar system? The distance between Earth and the Sun is about 149.5 million kilometers. Earlier, we mentioned that special units of measurement are required to express the distances in space. This distance of 149.5 million kilometers is known as 1 astronomical unit. You might think, is that all? But remember, it's all relative. Even light, the fastest thing in the universe, takes 8 minutes and 20 seconds to travel 1 astronomical unit to reach Earth. If we wanted to pay a friendly visit to Jupiter, we would have to cover a distance of 5.2 astronomical units. The shortest distance between Jupiter and Earth is 588 million kilometers. The Juno spacecraft took 4 years and 11 months to reach Jupiter and enter its orbit. It would take even longer to reach Neptune, the icy guardian of the far reaches of our solar system. The distance from Earth to Neptune is 4.3 billion kilometers, which is 30 astronomical units away. Sunlight takes 4 hours and 15 minutes to reach Neptune. With the rockets we currently use to tour the solar system, it would take decades to get there. For example, the Voyager 2 spacecraft took 12 years to approach Neptune, while the New Horizons mission reached it in 8 years. Neptune is the outermost planet in our solar system, but there is still something lurking beyond it. If we looked at the solar system from afar, we might not even recognize it because of a thick cloud of rocks and ice. This is the Oort cloud, a spherical cloud of frozen objects that is theorized to surround our solar system. The estimated distance from the outer edge of the Oort cloud to the Sun ranges from 50,000 to 100,000 astronomical units. This distance is truly beyond imagination. The distances we can never cross. By now, you might start to think of our solar system as our grand home. In that context, the Oort cloud would be the very threshold of this home. Crossing this line would mean stepping into an unknown, pitch-dark, and endless world. Amidst the backdrop of trillions of shimmering dots, a bright light would catch your eye. This light serves as a beacon, like a lighthouse, guiding and beckoning us forward. It is the star system of Alpha Centauri, the closest star system to our solar system. This star system is 41.3 trillion kilometers away from the Sun, equivalent to 276,000 astronomical units. To describe such vast distances between celestial bodies, we use yet another unit of measurement. This unit is the light year. A light year is the distance that light travels in 1 year. The speed of light is approximately 300,000 kilometers per second. 1 light year equals 9.461 trillion kilometers. Now, Alpha Centauri is 4.4 light years away from us. Naturally, with our current technology, planning a journey to this star system is impossible. Why do we have to be so pessimistic about this? Let's consider the Voyager space probe for a moment. This probe travels through space at a speed of 17 kilometers per second. If we were to send it towards Alpha Centauri, it would take 75,000 years for the probe to reach its destination. And I repeat, this is the closest star to us. Even if we were to build a spaceship that could travel at speeds close to the speed of light, it would take 100,000 years to traverse the Milky Way galaxy. That is a distance of 10 to the 17 kilometers. It is hard to even imagine a number with that many zeros, isn't it? Beyond the Milky Way, we would see that our galaxy is part of a group known as the Local Group, which consists of over 60 galaxies. Galaxy groups span the vastness of space in an unimaginably grand scale. It would take light approximately 10 million years to cross this group of galaxies. The universe is packed with trillions of galaxies and galaxy clusters. If we were to successfully launch into space, we would eventually come across the Virgo cluster. This cluster contains about 2,000 galaxies of various sizes, including our local group. Researchers estimate that the diameter of this cluster is about 15 million light years. This means that even a spaceship traveling at the speed of light would take 15 million years to pass through the Virgo cluster. Moreover, to reach this cluster from our solar system, you would need to travel 53 million light years. Impressive, but also terrifying, isn't it? After leaving the Virgo cluster, we would encounter an even larger structure, the Laniakea supercluster. Laniakea means immeasurable heaven. This vast structure contains about 100,000 galaxies and the Great Attractor, spanning a diameter of 520 million light-years. Do you still think that the journey to Mars seems daunting? Even when carefully studying a map of the observable universe, we cannot locate our Milky Way galaxy. Finding Earth within that galaxy, even with a microscope, would be out of the question. In moments like these, we feel an unprecedented sense of fragility and insignificance. Why we cannot measure the size of the universe? Many researchers believe that the universe is infinite. Even if there were limits to the universe, it would be impossible to find them. At least, not in the near future. There are also limits to the range we can currently observe. If an observer stood at the center of our solar system, the observable part of the universe would spread out in a sphere with a diameter of 93 billion light-years. Imagine someone pointing a flashlight at a dark piece of land from a very high place. The observable universe is like that. Beyond the observable limit, there may be something, but it is impossible for us to see it. The unimaginable vastness of the universe is due to its expansion, which has continued since the Big Bang. Objects in the universe are moving away from each other at a speed of about 70 kilometers per second per megaparsec. Galaxies are moving away at such unimaginable speeds that we can never hope to catch up with them. When faced with the vastness of the universe, do not despair about how small you are. A new generation of researchers will surely come up with ways to travel through space quickly and comfortably. But that's a topic for another video. Until next time, goodbye everyone.